our study is using tree models to predict sales for Walmart product. Since weather is getting colder, people's buying behavior started to change. So, according to the previous study, non-catastrophic weather was proved to be an important determinant for demand for weather-sensitive products such as umbrella, heating oil, and ice creams. So in order to help retailers to optimize their inventory and their marketing campaign, we're here to predict the demand for commodities in certain weather conditions as accurate as possible. Started with data collections. The data we're investigating was collected from Kaggle competitions for Walmart weather-sensitive product sales prediction. There are 3 data sets that we downloaded. The first one is the training data set. It contains the unit of a product sold, the product ID, the date, and the store number. The second data set is the weather data set. It contains the station number and 17 specific weather features and the date. The third data set is the matching data sets for store number and the station number. Our study approach is, because there are 3 data sets presented, we need to merge all those data sets. So second is we generate some new features based on some information from our data set in order to facilitate our analysis. Thirdly, we need to deal with noise in our data set, which is the missing values. And fourthly, because different the same items in different stores might have different items numbers, so we need to separate each store so we can focus in on one store without the bias of different item numbers. And then we perform regression trees and gradient boosting algorithms on our data sets to find the pattern. And finally, we analyze the accuracy and comparing the 2 algorithms result.
We choose the decision tree algorithm because it's very popular, basic, and easy to visualize. It consists of the classification and regression. As we are going to predict the exactly sales number, so we choose the regression. Our main goal is to minimize the program here. Is calculate the mean square of error. We want to reduce this value. So the tree starts with its root node, and we set several splitters to split it into several nodes, and then add it at the leaves. The attribute selection rule is to choose the largest variance of each step, and the splitting value rule is to randomly select a start and traversely test all the values. Here is a sample. If we have a training set, and we are going to choose the first attribute, here is xj, and a splitting value, here is s. Then we separate the training set into R1 and R2 and calculate the mean value of its target value. This will going to be our first prediction as the functions here. And after we repeat several times of this step, we're going to have our final tree model is presents here is the addition of all the prediction. And we got our minimum value of this program. Here is a sample in our data set. It starts with here with the first minimum value of 91. Then we get our first splitters into 2 subsets, and then we get our second nodes here and end it with 4 leaves. This is a very simple value with the maximum step of 2.
Same as the decision tree, the final goal of gradient boosting is that we need to find a model that minimizes the sum of the loss function for all points. And this is a general form of the model built by gradient boosting. And we will start with a constant model, and then we will update the model each time using greedy algorithm and negative gradients. This is a negative gradients with respect to fxi. And how we use the gradient, negative gradient to update the model, then this is the algorithm. As I mentioned before, this is we start with the constant model that we will pick the C0 that minimize the loss function, the sum of the loss function, and then we will go into the for loop. The first step of the for loop is that we have to find the scheduled residuals, which is the negative gradient with respect to the fxi, and then we will get like n many scheduled residuals, and then we have to feed decision tree. We have to feed a decision tree to scheduled residuals, which means that we have to train it with with a new training data set that the xi is the original xi's and the y's will become to the scheduled residuals, and then we have to find the kth stage c, the coefficient. The coefficient have to minimize the sum of the loss function. However, it's same as here, but we update the model by the coefficient times the hkxi. The hkxi just represents the predict negative gradients. So if we found this ck, this optimal coefficient, then we can update the model by this is a previous model, and we plus the coefficient times the predict negative gradient. So the main idea of gradient boosting with the decision tree regression is that we optimize the coefficient c each time in order to make the approximation fx reduce as much deviation as possible compared to the last model. So and for each step, the predict deviation is based on decision tree regression fitting the current negative gradients.
In our project, we use two algorithms to predict the product sales in Walmart. And the first one is decision tree. The second one is gradient boosting. And from these two tables, we have the result that there are two weather-sensitive products, this one and this one, because we can find out their score is pretty high. And for the atom 86, this one, the score is larger than the rest atoms. However, the R squared value is very low, so it's a potential weather-sensitive product. And we can check our result from the figures, and it's about the predict sales number, and the blue one is the predict sales number, the green one is the true sales number, and for the first two, these are the weather-sensitive product. Also, we compared these two algorithms. We found out that the gradient boosting method performs better when the maximum depth of the tree is less than 5, and also with further increasing the maximum depth, the gradient boosting shows pretty well reliability, and also it reaches the optimal result much faster than decision tree. For the gradient boosting, the maximum depth is 5, and for decision tree it is 10. And And the reasons why these two algorithms is different because for the gradient boosting algorithm, the accuracy score is mostly based on many decision tree functions, which to minimize the mean squared error of the residual values in each steps. However, for the single decision tree, it most depends on the max steps. With too many max steps, the decision tree will not have enough leaves to predict the precisely product cells. Therefore, we have this result.